Hi, I'm Luke Lenzinger, student at Gold Lake High School, taking the Computer Science and Software Engineering course. Currently, we're in the third trimester, and we just did a project on Arduino, microprocessors, and breadboards. Me and my partner, Haven Barson, created a radar, at least we tried to create. We had some setbacks there. And up here you can see, I'm going to play a little video which walks through our project here. See the ultrasonic radar, the servo that would rotate it 180 degrees. We have the whole breadboard here. I'm going to pull up my code right now that we got from the person who created this sketch that we used to do this. Some failures we had with this included it not working at all. So I have a picture down here because this is what it should look like. We never got it to work. Um, so that was probably our biggest failure. And then that is also a setback that we had, was just we're constantly trying to figure out to get it to work. We're watching YouTube videos, using ChatGPT, editing code, but nothing seemed to work with the program we used called processing. It was just, we couldn't do it. Some accomplishments we got were it it would work, like the stuff on the breadboard, the switch to make the servo turn on and off would work, and all the wiring did work, so that was a very good accomplishment. That was positive. We didn't have too many breakthroughs. It was just a simple sketch that we followed. Um, I also learned about making a complete circuit, and for the circuit to work, it must be complete, meaning there must be a continuous path for electricity to flow from the power source, like a battery, through the components such as resistors, lights, or switches, and back to the power source. If there's any break in the circuit, such as loose connections or an open switch, the current won't flow and the circuit won't function. So this is how we got our switch to work. Let me try to go through the video here and see if I can get a close-up of it. The switch is right here, and if you were to switch it on and off, it would make it so the servo would turn on and off. And we also learned about resistors and using a volumeter. The process includes setting the meter to the resistance setting, making sure the circuit is powered off before testing so it doesn't break it, and then placing the meter probes on either side of the resistor, and then reading the value on the screen and comparing it to the resistor's label value so you make sure it is correct and you don't break it or fry it or do anything bad to it. And this also helps ensure the resistor is functioning correctly and hasn't been damaged. And if the reading is far off from expected value, it might be faulty. And over here, I have my code, or we have what the different pins do, the values they have. The intervals for the servo are down here. I gotta scroll a little bit. And whether things are outputs or inputs. We have the loop for the switch. If it's high, it's on. If it's low, it's off. And yeah, that's then the calculator for the distance on the radar. We had 40 and 20, so centimeters. It would actually, our radar picture over here that I have is actually also in centimeters. I don't think it would actually be 10, 20, 30. It would be 20, 40, 60. I think that's what it's saying here. And then the buzzer high for green. Also another else if statement. And then we also have our git crack in here with all our different commits that we had and stuff working. Right now I'm in the final one. We had the stable code. We had it also unstable because we had it messed up for a while and we finally fixed it. And that's about it for today. Thank you for listening to my vlog about Arduino microprocessors. Bye.